Alright, so welcome back to the OneClass stream. Again, my name is Joey. I'm going to be your math teacher for the session. So what we're going to do today is we are going to, if you're tuning in for the first time, thank you for watching. What we're going to do is we're going to answer a couple questions. We're going to answer a series of 10 questions, hopefully 10 questions for today within the next hour. And what we're going to do is we are going to verify solutions together. So here at OneClass, what we're doing is we're dedicated to educating secondary school students and also in the college and the university level in particular subjects in math and chemistry. And what we're doing is we're providing solutions to questions that you've frequently asked online. And what we're going to do is we're going to walk through our thinking and our thinking process, and we'll describe our solution, describe the answer to you, and to verify these solutions to make sure you have the best solutions going into your assessment, so into a test or an exam situation. So that's kind of a brief introduction of OneClass. Again, me personally, my name is Joey. I currently come from a background of a bachelor's of education. So I have, I'm an educator, I'm a teacher in the secondary school level, specializing in subjects in science, so in chemistry as well, and math. So these are my, those are my subjects of interest. So without further ado, let's get started on the set of problems that we have for today. Okay, so what we have here is we have, so it says, what is the compound interest on a 3-year $100 loan at a 10% annual interest rate? So what is a compound interest on a 3-year $100 loan at a 10% annual interest rate? So this here is my problem here. So you can take a moment to think about that problem here. So let's do this problem here. So it says, I'll write this down for you. It says, what is the compound interest on a three-year $100 loan at a 10% annual interest rate? So what is the compound interest on a 3-year $100 loan at a 10% annual interest rate? So take a moment to think about these questions. Again, we have to think about what is the definition of a compound interest, and what are the variables that we have to find? Like what are some things of interest, right? So I'm gonna try to highlight these for you. So on a 3-year, so 3 years is important because they're talking about what the time. This here would be times. We have $100 loan, right? $100 loan. So this here is our initial principal. We can call it a principal balance. And then we have our actual rate, right? The interest rate here. So we have these three things, and it's an annual interest rate, right? So this here is the number of times. This here would be our N, right? So here, what I can do is I can write our formula. So I have here, it says A equals. So the compound interest formula is A, which is our final amount, equals P, our principal amount, as denoted here. This is our principal. This here is our T, which is our time. 10% is our rate, which is R. Annual interest is number of times interest applied per time period. So this is, you can think of it as cycles. So I have P times 1 plus the rate divided by N, which is the cycles, to the power of N times T here. So let's plug this formula in, and let's see if we get our correct answer. We have A equals, we have $100 loan, so this is P is our $100 times 1 plus R, which is our rate, right? And it's 10%, so we need to convert it to our decimals here. So this is 0.1, right? 0.1 divided by N, which is an annual interest rate. So annual just means 1, right? So per year, it's just 10%, right? So it's divided by 1 to the power of N, which is again 1 times times time, which is 3 years, right? That's what we have here. A equals, sorry, just give me a second. We have A equals, sorry, clear my throat here. a equals 100, and we do the brackets first, right? So it's 1 plus 0.1 divided by 1, which is simply just 1.1 to the power of 1 times 3 is 3, right? 3. And we do the exponents first. So a equals, what's 1.1 to the power of 3? Let me do it on the calculator. It is 1.331. 100 times 1.331. So my interest would be 100 times 1.331, which should be $133.10. So $133.10. So this here would be my compound interest, or the amount of the total amount that we have to pay back. But we're only focused on our interest, right? So this is A, here's our total amount. So remember, A is total amount, right? And this equals 133.10. So what we have to do is we have to actually take the loan out of that, right? Because we loaned $100, right? Because we only care about the interest here. So the interest, again, I can say I equals total amount minus our principal, right? So interest is $133.10 minus $100 was our loan, right? So our principal loan, which means interest itself is simply just $33.10. So this here is our final answer for number 1. So let's look at the solution together. So let's look at the solution. So it says given principal 100, annual 10%, annual interest rate is 10%, time period is 3 years. We are to find compound interest, right? So they have the correct formula here. They are divided by 100. R equals 10. Yeah. Okay, that's good. 1.1. This is correct here. I don't like how they didn't put the time cycles. So if, for example, if the interest was compounded bi-yearly or monthly, then they would have to account for that there. But in this case, we don't have to. Yeah. So $33 is the correct answer. This here is a great solution and analysis, right? So what they did was they calculated the total amount first, and they took the interest rate. So the compound interest is I here, and this is amount minus principal value. So the exact same thing here, and they got $33.10. So great solution and analysis. This here is solution is correct. Okay, sweet. So this is number 1. Let's look at number 2. My throat's kind of raspy today. I don't know why. I need more water here. So, sorry. So this is number 2. This is which equation has x equals minus 6, right? Which equation has x equals negative 6 as the solution? So we have all these ones. We have all these multiple choices here. So we're given 4 equations. We have to know which equation has x equals negative 6. So let's solve all these equations here. Let's do A first. So A is log base x 36 equals 2, right? So in order for us to do this problem here, what we're going to have to do is we're going to have to do we have to move log to the other side, right? If we move log to the other side, what we're doing is we're taking the inverse of logarithm, which is exponent, right? So in order for us to do that, we're gonna have to move log x to this side here, and when we move it to the other side, we're going to get 36 here. So we're just left with 36. So let me draw this out. So if I move log x to the side, I'm doing the inverse option, right? So inverse of log is exponential, right? So knowing that, what I can do is I'm left with 36 on this side. I have equals 2 to the power of x, right? To the power of x here, to the power of x, right? So again, and once I have this, what I can do is I can take the log of both sides to solve for this problem here, right? So I can do log 36 equals, this is log to the power of 2 to the power of x. I'm taking log of both sides. What I can do with my logarithmic rules is I can bring this x down to here. So I would get log 36 equals x log of 2. And then what I can do is I can then move log 2 to the other side and divide both sides by log 2. So log x equals log 36 divided by log 2. And this here I can plug into my calculator. So x would equal, let me see here, log 36 divided by log 2 would get me like 5.17 or something like that. So 5.1699 or something. So if I take, again, I can plug it back into my my x here, and I get very, very close to 2. So this here is my answer for a, which is not x or equals 6, right? So this here is a here is not the correct answer. Okay, let's do b now. Log base. Let me just check this answer. 5.7 equals of 36. Yeah, it's about 2. 2 to the power of, yeah, about 5.17 here. Okay, so let's do b here. So b here states that log of 3 is 2x minus 9 equals 3, right? So I have, again, what I'm going to do is I'm going to move log 3 to the other side. So move log 3 to the other side, I get 2x minus 9 just by itself. And I already have the base of 3, right? So it's going to be 3 to the power of 3 here. So I'm going to have 2x minus 9 equals 3 to the power of 3. 20 is 3 cubed, right? Which is 27. And then I simply just solve this as an algebraic expression, right? So I'm going to move minus 9 to the other side. So I'm going to add positive 9 to both sides. So 27 plus 9, here is 36. X would divide both sides by 2. X here equals 18. So B is also does not have it as a solution. So let me look at C now. C here is log 3 of 216 equals x, right? So I can do, so this one I don't have to actually move it. But what I can do is I can actually, if I want to plug in my calculator, I can do log, I can do the change of base, right? So we can say that log of 216 divided by log of 3 equals something, right? So I'm doing a change of base in this case. So I can say that log 3 of 216 would equals 4.89. Give me a second. Let me just check this. 4.89. Yeah. So I can do a change of base. X equals log of 216. So instead of base 3, I'm changing it to a base 10. Log of 3. And then you can plug this in your calculator. And you get log 3, 216. You get 4.89. Which again is not my answer here. So D here, let's see if I have any luck in getting x equals negative 6. It's log of 3, base 3 times negative 2x minus 3 equals 2. So what I can do is I'm going to move log 3 to the other side. If I do that, it's going to be negative x minus 3 equals 2 to the power of 3, right? To the power of 3. So negative 2x minus 3 equals, 2 to the power of 3 here is 8. And then I'm going to have minus 3 moved to the other side would be plus 3. So I have negative 2x plus 3 is 11. X would equal negative 11 over 2, which means that's not the solution here. So for some reason, I'm not getting a solution for x equals negative 6. So let me just check the solution to make sure we have something here. So what they did was they actually put x into the solution. So that actually probably makes more sense for us to do that. So for A, they plugged in -6, and this equals 2, right? So in this case, what they did was they plugged in x equals -6, but in case you can't, logarithms are only defined for positive real numbers, right? So the log of -6, log base -6 of 36, and again, you're going to get a math error, right? Because you can't take a log of a negative number. So A is definitely incorrect here. That's fine. B here, we had B here, this says if you plugged in -6 for this x value here, you would get log of 3 equals 21, right? So -12 minus 9 is 21. And this here is not true, right? Log base 3 of -21. Again, you're into math error because -21 is not, you cannot take a log of a negative number. And then I have the third option here is log base 3 of 216. If you plug that in, here is 4.89, right? Like we did here. So this term is wrong here. And then lastly, I have this here is -2x minus 3 log base 3, right? So they plugged in -6 here, and they got a solution. Okay, so the reason why they got a solution was they actually plugged in -6 here. So let me just do that work for you instead of, because what I did was I solved for x instead of actually verifying x as a solution. So I approached it the other way, and sometimes that might not give you a right answer. So in this case, it doesn't. So log 3, I'm gonna sub in -6 minus 3 here equals 2, right? So log base 3, -2 times -6 here is -12 minus 3. Sorry, it'd be positive 12 minus 3. Right? -2 times -6 is positive 12 minus 3 equals 2. Log base 3 at 12 minus 3 here is 9 equals 2. And then obviously 2 equals 2. Right? So this here is my correct answer, because log base 3 of 9 is 2, right? So this here is my correct answer. Therefore, D is here is the solution. So that's good. Or you can say that we can say what they did here was they just moved log 3 to the other side, and it still works as well. So let's see. I think I made logarithms the base actually. So that's actually my fault. Okay, so let me I'm gonna redo my math here. So I think my math was wrong. So what I did was I actually placed it in terms of the exponent and not the base, and that's my fault here. So let me solve for x again. Sorry folks. So if I move log 3 to the other side here, I get -2x minus 3 equals, this is 3 squared, not 2 cubed. Remember, the logarithm here, the base here, is also the base at the bottom. So that's actually my fault. I put it as exponent here. So this is -6x minus 3 equals, this here is 9. And then I have -x minus 3, which means it's positive 3 on the other side, right? So 9 plus 3 here is 12, and then x would equal -6, right? I'm dividing both sides by -2, I would get -6. So D here is my solution. So that's my fault, sorry. I put it as the exponent and not the base. So totally my fault. So this here is rate, solution, and analysis. Sorry, folks. So this here was 2, question 2. Okay, let's do question 3 here. So it says read the numbers and decide what the next number should be. Okay, so you have a pattern some sort. So you can think of it as a series and sequences. You have 1, 3, 4, 7, 11, 18, and 29. So it says decide what number come next. So when we look at these ones here, we can actually look to see if it's algebraic or geometric, right? We can see if it's a recursive sequence and whatnot. So let's look at this problem, and maybe I'll pause here and think about what kind of sequence can you see in terms of these. Can it be an arithmetic sequence or a geometric sequence? What do you think this sequence would be? So let's take a moment and think about this problem here. I have 1, 3, 4, 7, 11, 18, and 29. So let's see. Let me see if I can find some patterns here. So I have 1 and then 3 and then 4, right? So I know 4 is a sum of 3 and 1 here. So 4 here is a sum of the previous two numbers, which is 3 plus 1, right? So that's equals 4. And 7 here is a product of the previous two numbers, which is 4 plus 3. right? So I can kind of start to see a pattern here. 11 here is 4 and 7. It's a product of 4 and 7. Sorry, the sum of 4 and 7. And the 18 is a sum of 11 plus 7. And then 29 is a sum of 11 plus 18. So which means the next pattern, in this case, the next number here of x, so x would equal simply just the sum of the previous two numbers, right? So it would be 18 plus 29, which would equal, this is 47. Here is my correct answer. So let's see what they did here. They did here. Therefore, the next term of sequence, again, they actually give the nth term is given equal to the sum of n minus 1 nth and n minus 2 nth term, right? So basically it's saying that this x here, the sum of these two numbers, can be algebraically visualized by the nth term, which is whatever this term is. So you can say it's the n minus 1 or the n minus 1 1th term plus the sum of n minus nth term, right? So in this case, the answer is 1, 2, 3, 4, 5, 6, 7, 8, right? So this here, the eighth term equals the seventh term plus the sixth term, right? 8 minus 2 is 6, 8 minus 1 here is 7th, right? So this here is the sum of these two numbers. So if you ask me, okay, what is the 100th term in this case? So let's say if x of the 100th term would be simply just the 99th term minus plus the 98th term, right? So that's what we know from this problem here. It depends, the sequence depends on the previous two numbers. So that's this here is our sequence here. So this here is great solution and analysis. Solution here is correct. So that was question 3. Let's look at question 4. So question 4 states that how do you simplify e to the log x? Simplify e to the power of log x. So what is e to the log x? So again, so think about this problem here, and think about what is e and what is log x. So let's define e and define log x. So take a moment to think about this problem here. So let's define e. So again, e is Euler's number, right? And e here it approximately equals like 2.71, just like they stated here. So when we say this here, it's about 2.71. And when we say log x is the natural logarithm, right? Logarithm here. So when we take log e here is equal to 1, right? So we know that that's log of e equals 1. So we know all that stuff. So what about, and natural logarithms they follow the same rule as the logarithmic rule. So in terms of log and log, they all both follow the same logarithmic rules. So when we talk about e to the log x here, e to the log x here, that means if log e here equals 1, I can simply say that, or if I say, let's say log of x equals, let's say equals y. So x and y are just different numbers here, right? And if I take e and if I move it to the other side, I'm going to get x here equals, is going to be base e to the power of y, right? So base e to the power of y. So if I have something that's e to the power of log x, so in this case, if y, so let me hear, if y equals log x, then I have x equals e to the power of ln x. Ln x here, right? And this here would actually equal x would simply just equal x, right? It equals itself. And this here proves that these two cancel out, and it proves that x here, this entire thing simplifies to simply just x. So let's look at their solution here. There we go. So what they did was, so we have e to the power of ln x. We have to decide some variable to simplify in an easy way. So they wrote we have y equals e to the power of ln x. So that's what we have here. Y equals e to ln x. We take the natural logarithm of both sides. So you have ln y equals ln e to the power of ln x. And you have ln x divided by ln e, which is simply just 1. So ln y equals ln x, which means y here equals x. So in this case, this here simply just equals it equals x here. So this here just cancels itself out. So what they did was they did something like this. So they let y equals e to the power of ln x as their function here, and they took the ln of both sides. So equals ln of e to the ln x. So I have ln y equals, and then what I can do is I can move this ln x to the bottom, right? Ln x ln e, right? Ln e here. And then I have ln y equals, ln e we know is 1, like we said before, so this here cancels out to 1. Ln y equals ln x. And you can say the lns can kind of cancel out. You have y equals x, right? So this just means that it equals itself. So this here is a great solution and answer. So it just equals itself. So this here is 4. Let's do number 5. So number 5 states that based on the family of the graph belongs to, which equation could represent the graph? And then I see this graph here. Okay, so let's look at this graph here and say, and let's redraw this graph. So it's 1, 2, 3. So this here I have something like this, and this here is between 3 and 4. So I'm going to say this is between 3 and 4. And then the x-axis is, and then I have something that it's at kind of like, this is -1, -2, so it's between -2 and 3, right? So maybe something like this. So 1, so between -2 and -3. Okay. So based on the family the graph belongs to, which equation can represent this graph here. So as you can see, if you look at this graph here, it looks very, very similar to a reciprocal function. This here looks very oddly similar to a reciprocal function. Because a reciprocal function, if you recall, y equals 1 over x, has something like this, right? Like it looks very, very similar. It's just maybe translated or stretched or horizontally stretched or vertically stretched and compressed, right? So it looks very, very much so like a reciprocal function. So let me look at the options here. So we have option A, which is y equals log x plus 3. So in this case, if we graph log x plus 3, you're going to get a function that like basically steadily increases over time. So let me show you what that means using Desmos. So I have, let's see, log x plus 3. As you can see, it's steadily increasing, right? It's increasing at a very, very, very like kind of flat rate here, but it doesn't really like it doesn't have a negative. I can't take the log of a negative number, right? And in this case, it exists in the negative domain, so log x cannot be my answer in this case. Remember, log is just simply the inverse of an exponential function here. So which means A here cannot be our answer. Let's look at B. Let me bring up the graph here so you can see B here. let's do b. B is an exponential function. I have y equals 0.2 to the power of x plus 3. And if I sketch this graph here, again, an exponential function looks like this, right? If this was like 2 to the power of x. However, if my base here is between 0 and 1 here, I have a decreasing function, right? So I have something like this, right? I have a decreasing exponential function here. So again, I don't have, it only exists in the, in this case, the domain works, it's increasing this way. However, again, my y value cannot be negative, right? If I take the exponent of something, I can never get a negative value. It has a horizontal asymptote at y equals 0. So in this case, this cannot be our answer as well. And a decreasing exponential cannot be our answer here. So this here was a logarithmic. So this here, a logarithmic here. This here is a decreasing exponential. Let's look at C. C here is x cubed plus 3. If I were to graph x cubed plus 3, again, I have a polynomial function, right? Let me graph this for you in blue. X cubed plus 3, it's an odd function. And it's the leading coefficient here is 1. So I have here, it would be something like this, where this here is at 3 here, right? So this case, again, it doesn't look anything like a reciprocal function. So this here is the wrong answer as well. And finally, I have D. D here is y equals, I have 1 over x plus 2 plus 3 here. And this here looks like my reciprocal function, right? If I were to graph this function, it would look oddly, very, very much so like this, right? And to prove that, I can solve for the horizontal asymptote. In this case, it's here. I can set this value here, and I would get the y-intercept in this case would be indeed at y equals 5 here. Y equals 5 here, because if I set x as 0, I get y equals 5. Or that's my horizontal asymptote, and that would have another horizontal asymptote at x equals 2. So this here, again, it's my only valid answer, right? And then what I can do is I can actually check this graph on Desmos. So let's check this graph here and say that y equals, not y equals, I have 1 over, this is x plus 2 plus 3 right here. So I have, in this case, if you look at the function here, it actually does not match this graph at all. So the reason why here is that I looked, the graph here is actually wrong. I don't know who drew this graph, but this graph here is actually wrong. But it's the only, I think it's asking for the family of the graph and not specifically like the horizontal and vertical translations as well. Because if I look at this graph here, x plus 2, my horizontal asymptote is obviously here at 0, right? I set this entire thing into 0, and my vertical asymptote here is indeed at this here would be leading to minus 5 here. So again, this here is the wrong graph in terms of like when we talk about like translations and stuff. This is the wrong graph, but in this case, it would be our correct answer simply just based off the family of the graphs. So this here, option D is the correct answer. Incorrect here says y-intercept lies between 3 and 4. So they use actually y-intercepts and not families of graphs. So in this case, it's correct answer, but they kind of used the wrong concept, but used the wrong concept to solve for the solution. So basically, the correct answer to this in terms of like the concepts, we have to talk about the family of the function, right? So A represents a logarithmic function. B represents a decreasing exponential. C represents a cubic function, polynomial. And D here represents a reciprocal function, right? Sorry, reciprocal spelled like that. So in this case, based off graph, D is the only valid answer. However, the graph does not actually equal whatever they had here, which is 1, y equals 1 over x plus 2 plus 3. It actually does not equal that. So this here, I'll say solution is correct, but they're wrong. They're using the wrong logic here. So this is 5 here. That's question 5. So they just simply solved for the y-intercept, which is fine. It's actually a good way to solve for it. But remember, we're asking for the family of functions, right? So it's valid in some way, but they're using the wrong concept. They want you to be able to pick out what an exponential function is, a radical function, a reciprocal, etc. They want you to care about the family of the functions here. So I have another pattern here. It states, I'm guessing it's what's the next. The question doesn't say anything here. It just says the pattern, but I'm assuming it says what's the next number or something like that, or write a formula that depicts this pattern or sequence. So I have here's 1, is 1.25. I have 7, 7.50, and then I have 2, 2.25, and then I have 8, and then some value x, right? So take a moment to see if you can figure out the pattern here. So I have 1, 1.25, 7, 7.50, 2, 2.25. So look at this, find sums, find differences, and think about what would go next in the pattern. All right, so let's look at this here. So we have 1, 1.25. So let me take these two numbers. So 1, the difference between 1 and 1.25 is here is 0.25, right? That's fine. And then I have here 7 and 7.50. I'm looking at these two. This is a difference of 0.50. This here is a difference of 0.25. And this here is, which means therefore this difference here would be a difference of 0.50, right? It's the next logical pattern here, right? 0.25, 0.50, 0.25, 0.50. So these two are the patterns for these two. And let's look at, I'll do this in red. Let's look at the pattern of the whole numbers here. So I have 1, 7, 2, and 8, right? So 1, 7, 2, and 8, which means like if I look at the difference between this number and this number, it's simply plus 1, right? And then between this number and this number, this here is plus 1 as well. So so again, you can think of it as I'm skipping numbers here. I have 1 and then 7 and 2 and then 8, right? So you can say that the difference between these two numbers, 7 minus 1 here is 6, so it's a 6 is a difference here, 2 and 8 here is a difference of 6, right? Which means therefore my next kind of logical number here would be 8.50, right? X would be 8.50. And then the next pattern after that would be whatever 1, 7, 2, 8. The next pattern would be 3 here, right? 3 would be my next number after 8.0, and then it would be 3.25, and so on and so forth. So what we can do is we can actually write an algebraic equation. Then let me see if they do that here. I don't think they do that here, but they just use logic like I did to solve for this one. It says here, second term is obtained by adding 0.25. That's good. Fourth term is 0.5, and then the sixth term is 0.25. That's good. So every even, the even term is I'm adding 0.25 from the previous term, and then what I can do is I am going to add basically 6 from the odd terms, right? So basically I can say something like nth term would be, if I'm going from n to n plus 1 here, I'm adding 0.25, right? So n at 0 would equal, or n at 1, sorry, would equal n at 0 plus 0.25, right? And this is for every odd number, odd number. So let me do, this would be n minus 1, actually, not n to the power of 0 here, because I'm doing a general formula. And this is for every odd number here. So every odd number, I'll say maybe I'll denote this as x, where, so this would be n x minus 1, or this would be nx minus 1 plus 0.25. And then the next one would be 0.50, right? So where x here I can say is the, so 1, 3, and 5. This here's 1, 3, and 5. So it's every other odd term. So this here I have to state where x is every other odd term. And then for I can write another statement that says n equals, and at y would equal ny minus 1 plus 0.50, because that's the difference between here and here, right? This here would equal the previous value, which is this one, plus 0.50. This is for every, in this case, it would be at the third term and at the seventh term, and so on and so forth. So this one would be also where y is every other odd term. And again, I'm writing an algebraic expression, but in reality, we actually don't have to do this. Again, I don't know what this question was asking here. I'm just kind of extending the problem to show you some type of algebraic expression here to kind of model this. But you can actually just simply use logic to figure this out. But then, again, the next term would be 8.50, and then it'd be 3, and then 3.25, and so on and so forth. So this here, I'll just say great solution and logic. There was not a question, just a pattern. So I assumed that this question wanted what the next value in the sequence would be. Solution here is correct. Okay, let's do number 7. Number 7 says, which is the initial value that shrinks an exponential growth function by 50%? So it says, what is the initial value that shrinks an exponential function? So it says initial value that shrinks exponential growth function by half. So it says here I have an exponential function. So let's say, let me draw this out. So this here, exponential growth function. This here I'll say it is y equals 2 to the power of x. This here is my standard exponential growth function. So it says here, what is the initial value that can shrink an exponential growth by 50%? So let's say that I know here this is at 1, right? Let's say, what if y here equals, let's say let x here equals 3. So let's solve for this here. 2 to the power of 3 here is 8, right? So y would equal 8, which means 3, 8 is a point, right? So let me say this point here is 3, and this here is 8, right? Is 8. Oh, sorry, it's kind of messy here. This here is 3. I have the point 3, 8, right? I have the point 3, 8 in my function here. So it says here, initial value to shrink the initial growth function by half. So I want to actually cut this value by half. So let's say if y equals 4. So if I'm shrinking it by half, I'm taking the y value and I'm multiplying by half to get 4, right? So at 4, what is the initial value that shrinks an exponential growth function by 50%? So I have to solve for what is kind of this, where would y equal 4 be here? So let's say, so in this case, I'm solving for my x value now. So I have y equals 2 to the power of x. If y is now 4 to the power of x, I know that x here equals 2, right? 2 squared is 4, right? So again, this here, my new value would be at 2 instead of at 3. So in this case, I am going to have to, in this case, I prove that the growth function shrinks exponentially by half if I simply halved my y value. So I'm simply multiplying it by 1/2. So D here is true. So A is false because if I multiplied by a quarter, I would get the value of 2 and not 4. If I have the base function of 2, it will actually double in size, and you get 16 instead of 4. I get negative half, you actually get a reflection, and you start getting a decreasing function, right? If I plotted something like this, y equals negative half to the power of x, you get something. Actually, let me just do it on Desmos to save time here. Negative half to the power of x here. Oh, sorry. Let me just do negative 0.5 to the power of x. Does that help? Yeah. As you can see, your exponential function is now flipped, and it's a decreasing function, right? So if I had a function that was decreasing like this here, it would actually flip and do something like that. So you get this function here. That's this guy over here. So you get definitely not shrinking, because this is now heading towards 0. So the logical answer here would be D, and just multiplied by half. Value C cannot be negative. B is false, which is true, because it would actually increase the growth, and C here is half, right? So if you have half of A here is equal to 50%. So they actually solved for, they actually did the similar algebra like I did here, but I assumed a 0.38 where they kind of assumed a point which is 100%. So this here is great solution and analysis. Solution is correct. So this here's number 7. Let's do number 8. 8 says, which table shows no correlation? So let me write down. These are actually a pretty long question. So let me write down the table of values vertically, so it might help some of you out. So this is 3, 5. This is for A. 3, 5, 6, 8, 10, 14, and 15. Then I have negative 1, negative 2, negative 3, negative 2, negative 5, negative 4, and negative 8. So first, as you can see, my x values they're not linear, right? So it's not 1, 2, 3, 4, 5. It's not a consecutive, right? So what I have to do is I have to actually find some sort of I have to actually remove some of these points here just to make sure that my length here is there's a correlation here, right? So let's say and again, look at all these multiple choice here. All of these x values are the same. So I can actually rewrite this, and I'll write all 4 options here. And let me write the second option. So this here would be y. I'll say y at 1 here, and then I can do another graph and say that this here is y at 2, which is negative 6, negative 7, negative 4, negative 2, 0, negative 1, negative 3, right? This would be for this is A, this here is y, B, and they could do the same for C and D, right? So let me just work with A first. So it says here, do I have a correlation? So when we're talking about correlation, it has to relate to some sort of function, right? So as you can see, it's negative 1, negative 2, negative 3, negative 2, negative 5, negative 4, negative 8. These numbers are pretty in terms of we're using this definition of first differences to find some sort of correlation here. So it's going negative, I think it was going back to positive, and then it's kind of going back down and then going back up. So A here kind of doesn't look like a correlation. So A here, I can't really see a pattern here. Let's look at number 2. Number 2 is going down and then going back up, or negative 6. I'm focusing on the y values here. Negative 6, negative 7, negative 14, negative 2, 0, negative 1, and 3. So it's slowly going positive. This one here is negative 4, negative 2, negative 4, positive 6, positive 8, 12, 0, and 16. And this here is negative 3, negative 5, negative 9, negative 11, negative 13, negative 15, negative 16, right? So I think for 4, because it keeps going negative, I can see some sort of linear progression. 2 here, I can think of it as like some sort of like a parabola, right? Or quadratic maybe, because I have negative 2 and negative 4. So it's going negative first, and then suddenly it goes positive, and then goes back to negative. So some sort of polynomial function maybe here. And then for number 1 and number 2, I'm kind of torn, right? So I have here negative 6, negative 7, negative 4, negative 2, 0, negative 1, and 3. So it's slowly going up here, whereas this one is slowly moving down here. So I'm torn between 1 and 2 here in terms of which shows no correlation. So let me just see what they're doing here in terms of table of values. So first table of values, it says values of x are all positive real numbers and y are all negative numbers. So there might be a formula. Okay, that's good. Same for the second table where input is positive, output is negative. Okay, third table, as you can see, some outputs are some positive, so there's no correlation here. So they're saying that there's no correlation because there's negative and there's positive, and there's some correlation here. So they're saying that the third table here is no solution, or there's no correlation here because it's both negative and positive. So in this case, let me try to graph this actually. Let me try to graph C out, and just to see what type of graph they're looking at. It might be actually worth it to graph some sort of function here. Just see. So I have 3 and 5. So say 3. Here's -2. So here's maybe here. 5 is at -4. So maybe here. 6 is at all the way here. 6 is here, right? And then 8 here would be 8, which is like kind of up here. Sorry, you can't see that. 8 up here maybe. And then 10 here is at 12, which is even higher. And then again, this is just sketch, right? 14 and 15, this is super high and then goes up to super low. So you have something like this, right, as your kind of pattern. And again, this could be a function. We're actually not given enough information to tell us if this is a function or not. But basically, I think based off these values, I have here, this is a negative value here, -1, -2, -3, -2, -5, -4, -8. And then same with the y value here. This is it's mostly negative numbers, and then it goes positive. So in this case, honestly, like you're actually not given enough information. So a table of values, finding first, second, third differences would not get you a solution in this problem. So table of values is not enough. Table of values is not enough to verify this solution in determining if there is a correlation. So basically, I'm saying that there's actually not enough information in this question for me to solve for a solution here. But I can see the argument to say that, oh, there's positive and negative, which means it goes up and down. But this here could also be a function, right? This here could be a correlation, some sort of. So in this case, I'm going to say solution is correct, but I don't think a table of values is just a bad question in general. This is not a great question. Whoever posted this, it's a problem inherently with the question here. So I'm going to just say table of values is not enough to verify the solution, but I guess in this case, the definition here, they're saying it's both negative and positive, so it's more likely that it's probably not a function here, or not. There's no correlation. However, I do see the argument in saying that y values are both negative and positive, meaning that there is no correlation. And if we want to be really, really aggressive with this, we can actually use statistics to prove whether or not there's a correlation. Right? We can calculate the R value when we have a table of values and prove that, but I don't think that's kind of the extent of the question here. We could actually calculate R values and calculate some sort of correlation depending on that using linear regression, but don't worry about that. It's just more statistics than if anything. But I'm going to say here, solution is correct, but again, it's a bad question in terms of like it doesn't give us that much information for us to work with here. Let's look at number 9. Number 9 will probably be our last question. It's probably take me about 5 minutes to do here. So it says here 9. So if f of x equals 16x minus 30. So if f of x equals 16x minus 30, and g of x is 14 minus 6, for which value of x does f minus g of x equals 0? So what I have to do is, this is a composite kind of function, right? Or not a composite function, but I'm putting two functions together, right? I have f minus g of x, right? So f minus g of x means that I have this here, f, so I can say that f minus g of x equals f of x minus g of x, right? So then what I can do here is I can simply sub in 16x minus 30 for f of x minus 14 minus 14x minus 6, sorry. 14x minus 6, sorry. Minus, and this is 14 x minus 6 here, right? And you need the brackets here because I'm subtracting all the negative stuff here, right? So this here is 16x minus 30. So I have minus 14x plus 12, right? Because I have my negative 14x here, and then negative and negative here becomes positive 12 here. 16x minus 14x is 2x. I'm collecting like terms. Negative 30 plus 12 here would be negative 18. And then what I'm going to do is I'm going to set it to 0, right? So f minus g of x, set it to 0, right? So I'm going to set this function to 0. So I have here, this here would be f minus g of x. So now I'm going to set this function to 0, right? So let me set this function to 0. So 0 equals 2x minus 18. I can move 18 to the other side, so I'm adding 18 to both sides. I have x 18 equals 2x. And then finally, I can divide both sides by 2. X equals 9. So this here is my correct answer for this function here. And let's see. 16x minus 30 minus 14x minus 6 here. Did they sub in the problem correctly? F minus g of x, right? Yeah, f minus g of x. 16x minus 14x. Okay, they're grouping it, and I have negative 30 plus 6. Did I do my problem wrong? Oh, why did I have a 12 here? Oh my gosh. This here is negative. This here is positive 6. Sorry. I messed up here. I don't know why. I think I multiplied the function here by 2. So I'm sorry. I don't know why I did that. That's sorry. So my solution here is wrong. So I don't know why I got 12. In my head I multiplied it by 2. So sorry about that. 16x minus 14x here is 2x. Minus 30 plus 6 here is negative 24. Yes, and then sub in 0 here, 2x minus 24. And then I can add both sides by 24 to get 2x. Divide both sides by 2, x equals 12. This here is my correct solution. And x here is equal to 12, which is my solution. Again, so I like how they did some negative both sides. I don't know why I put 12 here. That's my fault. Sorry. Man, I made the two mistakes already today. It's not that great. That's okay. Math is about correcting yourself anyways. So I've 16x minus 14x is 2x minus 24. That's good. Now I can sub in 0 and divide both sides by 12, and I get 12, which is good. So this here is great solution and analysis. So that's going to take me to about 1 o'clock here. Again, thank you so much for watching my stream here. And again, here at OneClass, what we're doing is I'm basically streaming Monday to Friday. I'm providing solutions for math and chemistry problems. Again, if you're in the chat, again, thank you so much for watching this stream here. And as always, stay safe, stay healthy, and keep learning despite all despite this COVID-19 situation. I'm going to stream again back on Monday, and I'll be back with a brand new set of math problems, and we can go from there. So as always, take care, have a great day. Thank you for watching, and stay safe, folks.